So we are saying domain and range of composite function. A statement. There are two things. The domain of the range of the composite function f of g is the intersection of the domain of the answer and the domain of the inner function. In this case, it was G. 2. The range of f of G is the domain of f of G inverse. So that the domain, so that the range still the domain to form the same category. So that the range of f of G inverse of x is the domain of f of G. For the domain of f of G inverse is the domain of the answer and the domain of f inverse of x, meaning we're getting the intersection here. The intersection. That is what you are asking, Natasha. So that if you're having normal functions, they ask you for the domain of f of x is the range of f inverse of x, and the domain of f inverse of x is the range of f of x. That's why whenever they ask you to find the range of a function, you find its inverse and then get the domain, because that's the relationship. Okay, let's now go to question 3. A. 1. Compute the square of the quadratic function f of x is equal to 3 plus 2x minus x squared, and sketch the graph indicating its turning point and the x and y intercepts. Compute the square. First thing is I write this function in that order, then I factor out the negative, then I divide this coefficient of x by 2 and then I add it. So I'll get 1, then I square it and then subtract the very quantity, and then I bring back the 3, so that now I get this first number here, x, I get this sign, negative, I get that inner number there, 1, taking the brackets, square, and then square that number, and then leave like that. Then I have x minus 1 squared minus 4. Then I expand now. I multiply throughout by the negative, so that I have negative x minus 1 squared plus 4, like that. From there, say, okay, I'm done computing the square. What's the next question? Next question is sketch the graph indicating its turning point and the x and y intercept. So I first get the turning point, which is what? That number there, the opposite of it, because I'm getting x minus 1 and equate it to 0, so that I get x is equal to 1. So I have 1 comma, this number the way it is, comma 4. Okay, is it maximum or minimum? I go back and check the coefficient of x squared. It is negative. So I'll say, since a is less than 0, then this guy is a maximum point, maximum turning point. Now I look for the x-intercept, or the easiest first, the y-intercept. When I take x to be 0, the value of y will be 3. Then the x-intercept now, you go to the computed square thing here, get it, and equate it to 0. This will go that side, so you have x minus 1 squared is equal to negative 4. Divide by negative 1, divide by negative 1. So you have x minus 1 squared is equal to 4. Square root, square root. So x minus 1 is equal to plus or minus 2. So x minus 1 is equal to 2, or x minus 1 is equal to negative 2. So x is equal to 3, or x is equal to negative 1. Then you sketch. The turning point is 1, 4. So you have 1, 4. And the intercept is 0, 3. So obviously to pass like that, then go that side. Where this one here is negative 1, and then positive 3. And then this is 3. So this is your f of x, passing through the correct points. If one of these pass through a wrong point, you may lose all the marks there. Can I take questions? You cannot write an exam and this question is not there. And that exam is not 100. This question, complete the square, will be there. And sketch the graph. Sketching the turning point. Sometimes they can ask you to sketch the line of symmetry. Line of symmetry is when you say x is 1 here, and you pick this, you take to the point. Before you take to the point, this x is equal to 1 is the line of symmetry. If they ask you for the line of symmetry. The x coordinate of the turning point. Sometimes they'll just ask you for the maximum value. You say the maximum value is 4. In that case, f of x is equal to 4. That's how you get all those. Then you should start giving me stories. I'll just tell you, I'm speechless. And keep quiet. So you have this question. Find the range of values of k for which a quadratic equation this has complex roots. To have complex roots, it means that the d, which is b squared minus 4ac, should be, the d should be less than 0. Okay, so find the values of k which will make the d to be less than 0. But what is the d? The d here is b is 2 minus k, the coefficient of x, minus 4, a is the coefficient of x squared, which is 1, c is this constant here without the variable, 1 minus 2k. You want this to be less than 0. So you are saying, first you expand, you get 4 minus 4k plus k squared minus 4 plus 8k less than 0. Then you say k squared plus 4k is less than 0 because this 4 and that 4 cancel. Then you have k plus 4 less than 0. So you get the critical points. K is 0, k is negative 4. And then form a table, negative 4, 0. Pick a number in between, pick a number after 0, a number before negative 4. And then get k plus 4, and then get the product. So this is a table of values. You press negative 5 here, get a negative, negative 5 a negative, so here it's on positive. So minus positive. If you're arguing, you try your numbers there. Then you want the part which is negative, so you want this section. So you're saying k must, oh, just say solution set. Just say solution set must be negative 4, 0. That's all. You don't include them because if you include them, you mean it can be 0. But if it is 0, then you get the real roots. But here you just want complex roots. Yes. Not whenever you see them. When you see, then you read the question. If they're asking for the interval, introduce the critical point. B.
So you are saying that if they are asking for the interval, then we just leave it here on k plus c on the final stage here before getting the critical point.
If they're asking, no, here we've been asked for the interval. So whenever they're asking for the solution set for the interval, that's a solution set. You go all the way up to the table, then you get that. Those who like the number line, you go up the number line, then you get your solution set.
When do we leave it somewhere here? Like when it's k plus 1 less than 0.
when they ask you to find the x. When they say so for x. That's when you leave it there. So we got B, solve 2x plus 1 is equal to root x plus 1. Solve each of the following equations, meaning solve for x. So this kind you can square, is fine. You square here, you square there. So you have 2x plus 1 is equal to x plus 2 root x plus 1. Then you bring this to the other side and the 1. So you have 2x minus x, 1 minus 1 is 0, and then you get this. Then you square again. So you have x squared is equal to 4x. Then now you have x squared minus 4x is 0. So you have x minus 4 is 0. So x is 0 or x is 4. Then you try and see if it's true. If x is 0, you have root 1 is equal to 1, which is true. If x is 4, you have 4 by 2 plus 1, which is 9, which gives you 3. On the right hand side, you have 4 plus 1, which is 2 plus 1, which is 3. So both of them are correct. So you say, therefore, x is equal to 0 or x is equal to 4. If one of them fails, you throw it away. This is why it will be a bit hard for you to fail the test, the exam this time around, because questions like this, question 2, you can get everything. Question 3, you get everything. Plus your CAs are good. Unless you messed up, there.
Sir, our CAs are what?
Are good.
That's why it would be wrong to divide the x there.
To divide the x, you don't divide the variable.
Oh.
Because if you divide it, then the x is equal to 0 won't be there. It will just be x is equal to 4.
I have a question. Why is it that some inequalities require finding critical points and a testing table, but then some of them you can just solve them directly?
You only solve directly those which are not fractions and are not products. If it's a product, you require a table. If it's a fraction, you require a table. None of these requires a table.
So I can't answer it direct and get a half mark.
It's not possible. Why do you want to leave marks that are easy to get? You just put up a table and get the solution set. Then forget about it. Start thinking about going to anything.
Because then with the table, finding the values that are greater and less than the required figure is a bit tricky. Everybody is supposed to have the exact same values.
In maths, yes. All the point in the sports, so must give the same answer.
Exactly. So some of us, our values are different to others.
That is dangerous. The second one, 2x minus 3 is equal to 3x minus 5. So you redefine. You say 2x minus 3 is equal to 3x minus 5. If you want, you can use this. That is, if 2x minus 3 is greater or equal to 0, then you put a negative, open brackets, and then close if 2x minus 3 is less than 0. So that 2x minus 3 is equal to 3x minus 5. If I want again, I will simplify this. I'll say when x is greater or equal to 3 over 2, And also I multiply the negative now here. I have 5 minus 3x when x is less than 3 over 2. Then now I start picking 1. 2x minus 3 is 3x minus 5. So I take this side, this side. So I'll have 2x minus 3x is equal to negative 5 plus 3. So 2x minus 3x, I get negative x. Negative 5 plus 3, I get negative 2. Divide by negative 1, divide by negative 1, I have x is equal to 2. Or 2x minus 3 is equal to 5 minus 3x. Take this side, take that side. I'll have 2x plus 3x is equal to 5 plus 3. This is 5x is equal to 8. Divide by 5, divide by 5. Then I'll have x is equal to 8 over 5. So I have two values. You test all of them, they must work. So you test 2 first. 2, you have 2 by 2 minus 3. On the left, it will give us 4 minus 3, which is 1. Try it on the right, that will be 3, 2 minus 5, which is 6 minus 5, which is 1. So this is the solution. So this is part of the solution. X is 2. We now try 8 over 5. 8 over 5 minus 3. We get 16 over 5 minus 3. 5 down, you have 16 minus 15, which is 1 over 5. Then the other side, 3, 8 over 5 minus 5. You have, you have 24. That will be 24 over 5 minus 5. Common denominator 5, you get 24 minus 25, which is negative 1 over 5. Negative 1 over 5 cannot be equal to the modulus. So we discard this. So our solution is just x is equal to 2. Like that. Then these inequalities that are on question 3C, 1 and 2. We solved the exact inequalities in the paper that we did for 2018. Exactly. So you check there and be able to confirm that it is exactly the same. So questions? Any questions? Hello. I
Guys,
cannot.
if you guys need recaps or whatsoever, the thing is going to be uploaded on YouTube. So can we solve that question I sent you?
Which question?
I sent you a question.
That one was outside the outside coverage.
Also, I don't need to bother about it.
Those are just changing it to fractions. Those are simple things.
Yes.
So they just made a mistake in the book.
All right.
Recaps on modulus function. Modulus function. But why? Okay, maybe. Okay. This class will continue at I think at 7 or 8 tomorrow to finish this paper. Tomorrow is Tuesday, yeah. You still have Wednesday in between, okay. So we'll finish this paper tomorrow. I want to continue marking now. Okay. So you have a good night as you study. Most of these questions we have answered them already. Like question 5A, that's what came in your quiz, in your test yesterday. B, the sketch of sign. C, the equation that question 6A, these limits we have been doing them over and over again. Then B1, it came yesterday, except that on top there they put time. So you don't need to worry yourself. Okay, I'll finish this in the morning. Let me continue working. Make sure that you understand what you have done today and you try to solve the questions in another paper. You can pick 2016 or the same 2015 that you were solving, or the same 2018, because some of you might have forgotten what we did. So you can understand this section and do the one in 2018. When you finish tomorrow, you use it to do the ones in 2018 and 2015. Then you're ready for the exam. Don't need to stress. Two papers are enough for you to clear exam and charge.